Continuing from the last video where we created an actor component that allowed objects in our game world to spin, now I'm going to show you how to use some of the pre-built components within Unreal to create gameplay and mechanical assets such as a moving platform. In your content browser, right-click to create a new blueprint. Choose the actor class. Actors are any object that can be placed or spawned into the world, so this is almost all of the objects that you're actually going to be using in Unreal are actors of some kind, and I'm going to call this BP_platform. BP stands for blueprint. Open up BP platform. It's an empty blueprint with no components on it. So I'm going to go to the components window in the top left here, click add, and add a static mesh. A static mesh is a mesh that cannot be animated. It doesn't have a skeleton to deform it. The static mesh component has now been added, but there's nothing visible in the viewport because we haven't chosen a mesh to display. From this list, I'm going to type cube and try and find a cube from the list in here. Now that I have a cube visible, if you don't find all of the options available in the list here, once searching for your static meshes, click the cog icon next to the search bar and make sure that Show Engine Content is checked. Without that checked, you'll probably have a much smaller list of options to choose from. Okay, so I have a cube. It's not a terribly useful platform, so I'm just going to go into the transform options on the right-hand side and set the scale to something like 0.2, and I'm going to slightly enlarge this. There we go. You can see it's deformed the textures on the side of this mesh a little, but for the purposes of testing it should work just fine. I'm going to add one more component to this that will allow us to use it for a simple moving platform, and this is called the Interp To Movement component. Interp is short for interpolated. Interpolation is an easing from one point to another using a third value to control the two. So something like going from A to B over time is a kind of interpolation, or changing from one color into another. In this case, the Interp To Movement component, if we go into the details panel on the right hand side, allows you to set control points here under the Control tab. It currently has none. You can set up as many control points as you like, and it will automatically move between them all based on the duration that you enter here. So currently with no array elements and 1 second duration, it will go nowhere in 1 second. If I add 2 array elements here, so I have index 0 here and index 1. Index 0 is set to 0, 0, 0, which will be the middle of our platform here. Index 1 I'm going to change to 1000 in the z-axis. The z-axis being the the vertical axis. This second point should cause our platform to move straight up into the air. So I can place one of these into our game world now and test it. I compile the blueprint, save it, head back into our level. I'm going to take the blueprint from our content browser, drop it into the game world, and I'm just going to lift it up so that it's not smashed into the floor like that. I'm going to make sure I've placed it in front of the player start location just so I can have a look at it when we hit play. Sure enough, my platform disappeared up into the air very quickly. Just one more time. Whoop, there it goes, it's gone. The reason that it's moving so quickly is that the duration here in our BP platform is only 1 second. If I increase that duration to, say, 5 seconds, save it, compile it, back to my test level and hit play, it now moves much more slowly because it's attempting to complete that move over 5 seconds instead of 1. It doesn't just have to be 2 points like that. You can add as many control points in as you like. So, for example, 1000 in the X and Z axes should cause it to move off to the side once we spawn in. Yep, and I've now got a platform that moves between 3 different control points. The start 0, 1000Z, and then 1000Z and 1000X. Underneath the control duration and control points, you have this behavior panel. Currently, the behavior type for this platform is set to one shot. It will simply move through these control points in order 0, 1, 2, and then stop. If you change this from one shot instead to ping pong, now it will move down the array, and when it reaches the end, turn around and come back 0, 1, 2, then 2, 1, 0. In gameplay terms, this creates a platform that bounces backwards and forwards between multiple points, so the player can wait for the platform to come back. This is a very useful and simple mechanic. We can improve the ability to control this platform. Instead of hard coding these control points in, we can control them using variables that the user can set from inside the level, allowing you to position your platforms and position the destination for where the platform will move to without having to go into the blueprint and hard code it. First thing I'm going to do is delete the control points that we set up earlier by clicking on the little trash can icon. I'm going to leave the behavior at ping pong, and I'm going to come over to the construction script for this blueprint. The construction script is a really useful place for setting up variables and values before the user presses the play button or before these objects are spawned into the game world. We're going to need two variables to start with to control our platform's movement. I'm going to come over to the variables panel here, and I'm going to click the little plus icon to add a new variable. I'm just going to call this start pos or start position, and I'm going to set the variable type to be vector. A vector is an x, y, z coordinates, which means we can program in 3D space. Over in the details panel, I'm going to set this vector to be instance editable, just like we did on the spinny template earlier. This will allow us to change this from the level editor instead of the blueprint screen. And also underneath here, I'm going to click this box for Show 3D Widget. This will allow us to visualize the values for this vector in 3D space. I can show you what that looks like if we simply compile and save and come back to our test level. You can see the start position is shown here on the blueprint itself. If I click on it, I can then use the movement tools to change the start position's location in the level, not on the blueprint. This makes it much easier for your level designers to set up objects like this. So I'm just going to go back to, I can also change the value here in the details panel, just like we've done with previous values before, whichever way is most convenient for you to work, either setting them up precisely or setting them up using the on-screen display. Here in the platform though, in order to make use of these vectors, I'm going to create the second one now. It's exactly the same process. New variable, this one, end position. It is a type vector. It is instance editable, and I will show the 3D widget. Now, in the editor screen, we have two of these widgets that we can position, start position and an end position. But if I press play now, nothing will happen. We haven't told the platform how to use these vectors as control points. Remember, the InterpToMovement node uses control points in order to control which locations to move to. Here in the construction script, though, we can set those control points using code. Get a reference to the InterpToMovement node by selecting it in the Components panel, dragging it into the main blueprint window, and letting go of your left mouse button. Now that we have that reference in place, you can drag off from the little blue pin here using the left mouse button to obtain access to the different blueprint nodes that will affect the InterpToMovement component. For example, if I type add control point, I don't even need to get that far before we see a node is here for add control point position. The add control point position node does exactly what it sounds like. Through code, we can add a new position just like we did manually earlier by adding them into this list and altering the positional coordinates. This is just done using blueprint code instead. So we're going to connect that to the construction script start node. The blueprints operate like a flowchart with the origin point for the script entering here, and then the code will be executed following along the lines for these executionable pins along the white pathways. We want to take our start position vector from our variables component here on the left, drag it onto the blueprint and let go to get that value. We can then plug this into the position, and what this code will do is when this blueprint is compiled and constructed, the movement component will receive the start position as an input, and it will create a control point position based on the start position. In order to set up the end position, we just duplicate this entire process a second time. You can do that either by selecting the Interp To Movement components little node, dragging off, getting another add control point position node, or you can simply select it, copy it and paste it. Just remember to connect the movement component back up to the target, or this node does not know what the target of its function is, and then drag your end position into the blueprint and get that and plug it into the end position. You can also take a shortcut here instead. Select the end position from your variables list, and rather than dragging it into the blueprint and then selecting get from the options list, you can drag it directly on to the pin that you wish to connect it to. You'll see a little green checkbox appears on the screen, and when you let go, it will place the end position and connect it up for you. It's just a little bit faster, a little bit more convenient way of working. You can rearrange these nodes however you'd like to make it a little bit easier to read. You can also move them using the arrow keys on your keyboard if you want more precision. So this construction script now will add 2 control points to our Interp To Movement component here, based on the position of these 2 vectors, the start and end position. Let's see how that works. I'm going to compile the blueprint, save it, come back into our test level. Now that I have already positioned these start and end positions earlier, but let's just show you how you can do that again. These diamonds can be quite difficult to click on sometimes, but it's nice and easy if you use the right mouse button instead. Let's move the start position over here to the left, and the end position, I'm just going to move that up into the air a little bit. So hopefully the platform should move from the start position to the end position when I hit play. And there we go. So if I'm a level designer now, and I want to place multiple platforms into the level, I can drag one in over here, and this select the start position, move it, say, underneath this cube, and then the end position I'll place somewhere on top of the cube. I'll put another platform in over here in the background, and this time I'm going to take the end position and move it off into the distance, so this will float off into space. And I want to leave this first platform where it was right at the start. And when I press play now, all 3 of these platforms will begin to move on their own, with their own custom destinations and movement patterns, even though we use the same blueprint to set them all up.